Hello, in this video we're going to be talking about graphing quadratics by using intercept form. So our essential question is, what are some of the characteristics of the graph of f of x equals a times the quantity of x minus p times the quantity of x minus q? So first we're going to just dive right into our example of graphing from what we call intercept form. We call this intercept form because it is fairly simple for us to identify the x-intercepts of our equation. Our first step is going to be to plot our intercepts. So what we're going to do is we are going to let our y value here be 0, and this will help us solve for those x-intercepts. Since this is already in factored form, I know that each of those factors could be 0, which means that x plus 1 could be 0, or x minus 5 could be 0, giving me x-intercepts of -1 and 5. So on my graph, I put a -1 and a +5 as my two x-intercepts. Step 2, I use symmetry to help me find the x value of my vertex. So I know that my line of symmetry has to be exactly in between the 5 and the -1, which would be here at a +2. And to find that algebraically, all I'm going to do is add my x values and then divide by 2. So 5 plus a -1 divided by 2 gives me 4 divided by 2, which is 2. This is the x value of my vertex. So now that I know my vertex is on this line, x has to be 2, I just evaluate f of 2 to find the y value, or to find where exactly that x value is. Negative, and then I'm multiplying by an x value of 2 plus 1, and 2 minus 5. So -3 times -3, which gives me a +9. So my vertex has an x value of +2 and a y value of 9, meaning that my vertex is here, and my parabola is going to be facing downward when I connect those three dots. Step 3, we can verify by using our pattern. So here in this example, my equation has an a value of -1 if we're looking at the coefficient on the very front, which means that my pattern, which normally goes left 2 up 4, left 1 up 1, right 2 up 4, right 1 up 1, is actually going to be changed. We're multiplying all of those ups by a -1, which means we're going down 4, down 1, down 4, and down 1. So from my vertex, I will go left 1 down 1, and left 2 down 4, right 1 down 1, right 2 down 4, and had my graph been more accurately drawn, this pattern would make sense. So I just use that pattern to go ahead and quickly check and make sure that my parabola is at least generally accurate. Go ahead and take a moment, pause the video, and try out these couple on your own. Number 1, the first thing I'm going to do is to find my x-intercepts by letting y equal 0. So I have x-intercepts of -2 and +3, so x-intercept of -2 and +3, which means that my vertex can be found by adding those two values, -2 plus 3, and dividing by 2 gives me a vertex of 1/2. So this is actually not on an integer value for my x, and that is okay. Let's see what we're going to be right about here. My vertex is going to be somewhere along that line. To find exactly where, I plug in my 1/2. One-half plus 2 is going to be 5/2, and 1/2 minus 3 is going to be -5/2, which gives me a value of -25/4, which is going to be a little bit greater than -6. So my vertex is going to be right about here, and my parabola would look something like this. To check my pattern, now my A value in this case is 1, which means we would follow my normal pattern of left 1, up 1, left 2, up 4, 1, 2, 1, 2, 3, 4. And that does seem to be about accurate, so I'm going to go ahead and be content with the graph that I've got here. In number 2, letting y equal 0, I can find my two x-intercepts, which would be a positive 4 and a negative 1. So positive 4 and negative 1, which means that my vertex has an x value equal to half of the sum of those two intercepts, or 3/2. So my vertex is going to be right about here in between 1 and 2 at 3/2, or 1.5. To find the exact y value, I go ahead and plug in that x value. And I've got negative 2 multiplied by 3/2 minus 4 is going to be negative 5/2. And 3/2 plus 1 is a positive 5/2. Multiplying all of these together, I will have negative 25 over 2, or approximately negative 12.5, which is beyond my graph. So my graph will look something like this. Going back to check my pattern, I see that my A is a negative 2, which tells me that my graph should actually be facing downwards. So I'm going to run back through and figure out where my mistake was. When I multiplied, it looks like this is a negative 2 times a negative 5/2, which should make this a positive 25 over 2. So my graph would actually be a downward facing parabola with that vertex up beyond my graph at positive 12.5 or 25 over 2. To find zeros of a function, all we are doing is finding the x-intercepts. When we are graphing, we're going to have a very specific word, which is zeros, which means specifically we are finding the x-intercepts, or in other words, where the graph is equal to 0. So I want to know where f of x is equal to 0. So I just put a 0 in for f of x, and I solve, and I find out that the zeros of this graph are positive 1 and negative 2. So this is where my graph equals 0, or where the x-intercepts lie. Go ahead and find the zeros of these next couple functions. Our first one, f of x equals 0 at positive 6 and positive 1. And my second equation, h of x, is going to equal 0. When I replace h of x with 0, I have x is equal to 0, or x squared minus 1 is equal to 0. And then we need to solve this equation. Since it is x squared, I can factor using the difference of squares, x plus 1, x minus 1, which means that x could equal either 1 or negative 1. So this tells me that this graph actually crosses our x-axis 3 times. That would be at negative 1, 0, and 1. So this graph has 3 zeros, unlike a parabola or a line. So that tells me that this graph is not going to be either a parabola or a line. Instead, it will take on some other shape. And that brings us to the end of our introduction of graphing in intercept form. Thanks so much for watching, and have a great rest of your day.